Hello, I'm here to talk about capacity management and the cloud. Now, cloud computing, which has been around for several years now, many of us which we know what cloud computing is, but I'm just going to talk very briefly about how it's derived, what it's defined as. Now, by the National Institute of Science and Technology in the United States, they've defined cloud computing as three key elements. The first one being on-demand resources, the second one, rapid elasticity, and the third one, resource pooling. Cloud computing provides to us cloud services. Some of the more familiar ones that we're aware of are infrastructure as a service, platform as a service, and software as a service. And there are many other services available to us as time has gone on. The clouds that are available to us out there in the IT world are internal clouds or private clouds as we know them. So something that's very private or internal to your organization. There are public clouds such as the ones Google and Amazon provide to us. And then there's a combination of those clouds called hybrid clouds. And actually hybrid clouds are becoming more popular as security is improved and the security policies are more defined. Capacity management is even more important when it comes to dealing with cloud and cloud services. Why? If you think about what I just said in terms of the underpinning or the technologies that are provided, the resources, the rapid elasticity, it's all underpinned by the virtualization technologies that we have. So we're dealing with multiple guest operating system virtual machines running on shared infrastructure. But that shared infrastructure is actual physical systems, hosts, that are running a hypervisor. So ultimately, with virtualization underpinning the cloud, we still need to be aware of what we need to report on. What are the key metrics that we need to deliver the data for? What reports do we need to produce? What models or trends do we need to be looking at? It's still very, very important to identify within your cloud environment the performance and capacity hotspots. For example, if we think about the amount of demand for resources within your virtual infrastructure that's just backing up your cloud environment, think of it as a bathtub. That more and more requests for information is pouring through the taps into your bathtub. Now there are technologies out there such as VMware, Hyper-V that can load balance that demand for resources across clusters, for example. But think of it as the water rises in your tub. There is at some point that high water mark in your tub that's actually going to cause a performance issue. And at the point at which that's going to spill over the top of your bathtub. So what decisions do we have to make before that happens? One is, do we turn the taps off, which is ideally not what we want to do? Or secondly, when do we buy a bigger bathtub? Now, one of the key points that we can identify, certainly through using Athene and Metron Professional Services, is to identify something called VM sprawl. VM sprawl, where the ability to grow your virtual environment so very, very quickly can provide information about what virtual systems are idle, what virtual systems are oversized, and what virtual systems are undersized. Whether there are any performance conflicts, whether there's any complements, that kind of information that we can gather. And to provide the visibility that we need inside your cloud environment to produce meaningful performance and capacity reports, and to be able to provide the information necessary to make those decisions proactively before we get anywhere near an issue. So effective capacity management for the cloud allows you to instill something called continual service improvement. So that's analyzing or monitoring the right data, capturing the right information at the right level, analyzing and reporting on that right information, performing predictions, so forecasting on trends and analytical models to give you that information required to make those important business decisions for assurance purposes and for cost saving purposes. So within your cloud environment, avoiding things like cloud bursts, which can be very costly, but also identifying savings at the capital level, that CapEx level. So how many physical systems do you need to buy, and what are the right level of hardware that you need going forward? And also operational savings such as license costs, such as power, etc.